Hello friends, we are going to solve quadratic equations by completing the square. Completing the square always works, and completing the square is how the quadratic formula came about. Somebody got tired of completing the square and they thought there's got to be a formula for this, so they used completing the square to create the quadratic formula. When we complete the square, we do not want standard form. We want the variable terms on the left-hand side of the equation and the constant term on the right-hand side of the equation. So remember, standard form is ax squared plus bx plus c equals 0. We don't want it equaling 0. We want to move the c over. So we want it in the form where the variables are on the left and the constant is on the right. So when we go to approach this first question, we are going to rewrite it. And we are going to rewrite it as x squared minus 2x equals positive 36. So basically what I did was I moved the 36 to the other side of the problem. And I intentionally left spaces in the problem because I'm going to fill those spaces with the number that's going to complete my square. So I'm going to fill those spaces with a number that completes the square. Okay, so this is where I kind of diverge from most people who present completing the square, because I'm going to go to the next step. The next step, I'm going to change what I have here, x squared minus 2x. I'm going to begin, whoops, wrong color. I am going to open a parenthesis. I am basically going to take the square root of x squared, and so write x. And I'm going to take negative 2 and cut it in half and get negative 1. I'm going to close it, and I'm going to square it. And then I'm going to take negative 1 and square negative 1, which gets me plus 1. And that's what's going to go here and here. Okay, so if you missed that, here I'm going to show you what I did again. Let me bring it over here. We'll do it in a different color so you can see the pieces. I had x squared minus 2x. So what I did was I opened a parenthesis. I took the square root of this, and then I took this and divided it by 2. And I'm going to lose the x, sorry. And then I put it here. Then I put a square here, and then I took this right here and squared it, which is how I got the plus 1. So why do that? This is why. If you take x minus 1 and square it, that means x minus 1 times x minus 1, which is x squared minus 2x plus 1. So this statement right here and this statement right here are the same statement. The difference is this one only has the x appearing one time. Right there. This one has the x appearing in 2 places, here and here. And here it's squared. And here it's not. So that makes it really, really hard. Okay. Equals. And then, friends, 1 plus 36 is 37. So then we do solving by squares. So several videos ago, we did this. Remember doing this step? All right, that's this step. So we're going to take the square root to get rid of the square. That's going to leave us x minus 1 equals a positive and a negative square root of 37. And then we're going to solve the x by moving over the 1. And that's our answer. And that is our exact answer. That is our exact answer. If you wanted the approximate answer, the approximate answer would be like 6.1. All right, let's do another. All right. So the first thing that has to happen is this 73 is going to get moved over. That's going to give us 8x squared minus 16x is equal to 64. Up here, what I really should have put was, once I get it in this form, then what I need, it is in the form of x squared plus b over a, x equals negative c over a. In other words, I want the x squared term not to have a coefficient other than 1. So I'm going to divide this by 8, this by 8, and this by 8. That's going to give me a quadratic x squared minus 2x, oh, this one comes out to be the same, plus 8. Now I'm going to open a parenthesis. I'm going to put this number. I'm going to cut the next number in half. I'm going to close it. I'm going to square it. And then I'm going to take negative 1 squared. So now what I'm doing is I am taking, I just want to be clear on my color. Yep. I am going to take negative 1 and square it. And when I take negative 1 and square it, I get plus 1. So this equals 9. Then I'm going to take the square root of this side and the square root of this side, which will give me x minus 1 equals positive, oh my gosh, and negative 3. I say oh my gosh just because my radical took my equal sign too. Mrs. Leonard, you're so funny. There we go. And that gives me x equals 1 plus and minus 3. So I have x equals 1 minus 3 and x equals 1 plus 3. So x equals negative 2 and 4. So this one could have been factored. This one could have been factored, and it probably would have been very easily factored. Probably wouldn't have even had to split the middle. Probably could have just factored it immediately after taking out the greatest common factor. Okay, on this one, we need to rearrange things. We need to rearrange things. So the x squared stays put. The 7x has to come over here because I want all my variables on one side. And the 10 has to come over here because I want my constant on the right. Okay, so now I'm going to open a parenthesis. I'm going to take the square root of x squared, which is x. I'm going to take half of 7. Half of 7 is half of 7. I'm going to close it. I'm going to square it. Then I'm going to take this number and square it. And when I square it, I get 49 over 4. So this is going to equal, all right, this piece, I know you guys, this piece you're going to put in your calculator because that's just what students do. I'm not, because I'm not going to take the time to go get my calculator, i.e. I'm not going to open up Canvas to open up the calculator. I'm going to change 10 to negative 44s, and that's going to give me 9/4. So when you type that in your calculator, you're going to get 9/4. Or you can do it by hand like I did. 49 minus 40 is 9. All right. Then I'm going to take the square root of this and the square root of this. See, I can do that because completing the square took me from having an x squared and an x, in other words, x showing up in 2 places, to x just showing up in 1 place, which is ideal. All right. So the square root of this is going to give me x, whoops, wrong color. The square root of this is going to give me x plus 7/2 is equal to a positive and a negative 3/2. Because the square root of 9 is 3 and the square root of 4 is 2. So the square root of 9/4 is 3/2. So then I have the algebra problem, x equals negative 7/2 plus and minus 3/2. So that gives me 2 equations. That gives me negative 7/2 minus 3/2. And maybe, you know what, for this one, maybe I should write it like this, because I've been writing it the other way. So let's write it this way, just so people. So that would be negative 7 minus 3/2. And x equals negative 7 plus 3/2. Either way you slice it, this comes out to be negative 10/2, otherwise known as negative 5. And this comes out to be negative 4/2, otherwise known as negative 2. So x equals negative 5 and negative 2. And this one would have been factorable, so I would have picked factoring. But the goal is to practice how to complete the square. So let's do another. All right, so we're going to move things around. So the 6x squared needs to be the leader. The 12x needs to come over here. And the 25 needs to go over there. All right, now I do not want a lead coefficient that is not 1. In other words, I do not want the 6 in my lead. So that gives me x squared. My gosh, I'm in love with this minus 2x thing. And 18 divided by 6 is 3. This is x minus 1 squared. When you take negative 1 and square it, you get 1. And 1 plus 3 is 4. We are going to take the square root of the left-hand side. Therefore, we are forced to take the square root of the right-hand side. So x minus 1 equals positive and negative 2. So x equals 1, positive and negative 2. So x equals 1 minus 2. And x equals 1 plus 2. So x equals negative 1 and 3. And again, this would have been easily factorable, which I would have done. Alrighty. The variable terms have to go on one side of the equal sign, and the constant needs to go on the other side. Our lead coefficient already is 1, so that's golden. We are going to take this and make it x. We are going to take negative 8 and cut it in half. And that is going to give us negative 4. Hello, what is that? That's going to get us negative 4. We're going to close it. We're going to square it. We're going to take negative 4 and we're going to square it. And that's going to give us 16. And 16 minus 15 is 1. Then we're going to take the square root of both sides. And the square root of 1 is positive and negative 1. So I took the square root of this and the square root of that. Okay. So x is going to equal 4 minus 1, and x is going to equal 4 plus 1. So x is going to equal 3, and x is going to equal 5. Alrighty. Here we go. Oh, no. I don't know if I copied this problem correctly because I'm missing something. Well, you know what? Let's just do it with this, and if it just comes out to be horrible, you know I messed something up. Because I don't want to take the time to find what I had. Okay, let's say it was supposed to be that. Gosh darn it. So x squared minus 18x equals, it'll work. It just might turn out ugly if it's supposed to be another number over there. Okay, so we have that. We don't have, our lead coefficient is already 1. So I'm going to open a parenthesis. I'm going to go x minus 9 quantity squared. Again, if you're wondering where the 9 came from, I cut this in half. Then we're going to take the negative 9 and we're going to square it, and that's going to get us an 81. Why we did that in blue ink, I'm not sure, because it's part of the problem. So 117 minus 81, 8, 9, 10, 11. Oh, good. I don't think I made any mistakes. Is a negative 36. So then we're going to take the square root of this. We're going to take the square root of this. That's going to give us x, wrong color, x minus 9 equals a positive and a negative 6i. Again, if you're wondering where the I came from, the square root of negative 36 is the square root of negative 1 and the square root of 36, which is I and which is 6. Alrighty. You know what? That's driving me crazy. We're going to do it this way. We're going to write it properly. All right. Then we're going to move over the 9. So x equals 9 plus and minus 6i. So this one could have only been done with the quadratic formula or with completing the square, because it didn't come out pretty. It didn't even come out real. It came out complex. So this quadratic is not going to cross the x-axis. Okay, is that it? Oh, that's it. We are finished. All right, my friends. Let me know if you have any questions. Email me or ask me in class.